Hello YouTube, this is going to be my first video. I want to go over linked lists. This is a data structure that I really struggled on during my class. I got the idea of it, but never really understood what was going on, and I want to make a video about it. Yeah, I'm assuming you know what classes are and what pointers are for this, so I'm going to try to make it as simple as possible. This linked list that I'm going to do is um, a linked list that I personally found easy to understand. I'm going to try to go step by step and try to explain everything to the best of my knowledge. So yeah, let's get to it. So we're going to start off with a class called node, which is going to take an integer. Let's just call it value for now. And then we're going to declare a pointer node called next. Set this to null, ptr, and then a node last, and set this to null, ptr as well. So what this is doing is this next and last. So we're just gonna 0, 1, 2, 3, 4. These next and last pointers are going to be pointers for each value to point to the next node. So in this case, 0's last would point to null since it's the first. It's the head of the linked list. 0's next would point to 1. 1's last would point to 0. 1's next would point to 2. 2's last would point to 1. 2's next would point to 3, and so on and so forth. This is a doubly linked list. Very similar to a singly linked list. If it was a singly linked list, we wouldn't need this last pointer right here, and it would just traverse like this right here without pointing back. Just like this. But we are doing a doubly linked list, so we have it like this. And then we're going to do a constructor of node. So this is like a setter. We're going to be setting the value of value. So we make this constructor. So this is essentially a setter. It's a very simple setter. So we're going to go to the actual linked list. Now that we have our node, our class node declare. Oh, let me make this public for now. Class linked list. So in this class, we're going to have of type node. We're going to have head, null ptr. Uh-oh. Assign this to null ptr. Can't type. Oh my god. And then a node tail. Assign these to null ptr as well. Let me delete this. So this is going to be keeping, these two are going to be keeping track of what is the first and what is the last element in the linked list, or last node in the linked list. In this case right here that we have right here, let me just finish drawing this out real quick. Right here. No. So in this case, 0 would be our head, and our tail would be 4 in this case. So it's just to keep track of where we're starting off in the linked list. So now we want to do a add node function. So we're going to declare this as a void add node, and we're going to pass in a data type of no. We're going to reference our input, So we reference all of this stuff in here. So now we're going to, in this add node function, we're going to declare a node called current. You can name it anything really, but I'm going to name it current. And we're going to make it a new node and pass in the node dot value. What is this? Oh, sorry. I have it as, let's just call this node for now. Node. Oh, I can't spell. Value. There we go. So this is keeping track of the node that we input. So firstly, we'd like to check if the head is, if the linked list is empty. So by doing this, we're going to say if head, since head is keeping track right now, head is currently null, so it's empty. If head equals null, so if the linked list is empty, we're going to say head is equal to, oh sorry, not, let me change this to new node. There we go. Head is equal to the new node that we're inputting, as well as the tail. It's equal to new node. So here, if we inputted 0 for our node with a value of 0, head would equal 0, and then tail would equal 0 as well. It'd be pointing to the value of 0. Now, if it's already full, so if 0 is in there already, we're going to say else. We want the tail, so we want the last element of the linked list, which would be the tail. Tail dot next, or pointing next, is equal to new node. So say we want to pass in 1 as our next node. Tail next is in reality 0 next. And we're going to point that to be pointing to 1, the new node 1. So this is what this line of code is doing. Now we want to point back, so we're going to say new node last is equal to tail. So here we're saying this is our new node right here. This last one is pointing back to the tail, or to 0, right? And then we're going to make the tail equal the new node, right? So now 1 is equal to the tail. So in this case, we have it like this. Head and tail. And if we want to add more values, we just shift it over. And now if we added 2, this is what it would look like. Tail would be our 2 would be our tail now. Now to print this, we're going to do a void print list. We don't want to pass anything in here. And we're going to say node current is equal to the head. So in here, what we're saying is this current pointer is equal to whatever our head is. So our head is 0, so current is pointing to the address of 0. Or sorry, current is 0, right? Now we're going to do a while loop because we want to print it. I'm going to print everything in the linked list. So while current doesn't equal null. So here we're saying as long as current, since we're starting off here, current is the head, right, which is 0. As long as current does not equal null, we want to print current's value, do followed by a space, And now what actually traverses to it, we're going to say after this, current is equal to current next. So here we're saying since head is our current, we're going to print out the value. So we're going to print out 0, print 0, right? And then we move on to the next one. Current is equal to current.next. The next value of this is, let me just copy this. Current is, in our first loop, current is 0. Then we say current, which is 0, is equal to current.next. So we're assigning the next value into current, which is 1. Now we're 1. Is 1 equal to null? No. Here we go. We enter here. We print it out. Print 1. Now we go into 2. 2 is our new current. Print 2. What is the next one after this? Null. So we stop. This is where we would break. So we would print 0, 1, 2. Now, this is just a little simple linked list, but it's a way that I really understood it the most. So let's declare these stuff in the main. So we're going to say linked list list. So now this list function, or not list function, just this value holds everything in here. Let's make this public, sorry. Now we're going to say, let's make some nodes. So node 0, node 0, I'm going to pass by 0, sorry, input 0 for the value. Node 1, 1, node 2, 2, 2, node 3, right? So now we have our nodes right here. Now we want to add these nodes to the linked list. So by doing this, we just say list dot, and then here we have the add node function, list dot add node, and we pass our node into it. So node 0. Node 0, and then we say node 1, node 2, node 3. So now these nodes have been added to the linked list. They are all pointing to each other. Like in this picture, not this picture, this right here. Now we want to print it. So by doing so, we just say list, or let's say std cout this list. And then we're going to say list dot print list. So as you can see, I've already done it over here, but let's clear it and run it. So here we go. This is my list. Hopefully you'll like this little video on linked list. This is a way that I found really easy to understand. Let me know if there's anything y'all would like to change, or if there's anything that I should add to it. So yeah, thank you for watching.